Hello, everyone. We are Team Go Guardians, and we have taken up the sustainability challenge for Ansell. As two, our team members are Adnan, myself, and Haris, and we are presenting to you how we found this challenge to be and the solution we came up with. So we are trying to solve this problem for Ansell, where we want to effectively and safely store use PPE that's eligible for the right recycle program. As we all know, that this is a free program that Ansell offers to its customers, and it's supposed to turn in used PPE into recyclable products like lawn furniture, benches, shelving, whatever it might be. Some of the eligible items that the Right Cycle program does accept are the nitrile and latex gloves, protective gear like eyewear, apparel, masks, accessories, etc. So the challenge we primarily found that Ansel might be facing right now is that they want to separate their PPE by um, Kimtech and CleanGuard brands because their customers might be using some other brands, but the only brands that they accept are Kimtech and CleanGuard for the right recycle program. So we want to do brand segregation. So everything that's Kimtech and CleanGuard goes in one bin and everything else goes in the other bin. They also would like to separate it by material type. So anything especially the gloves that if they're made out of nitro, that should go in one bin compared to polypropylene. And the thirdly, they want to like also segregate by hazardous and non-hazardous PPE. So, considering these challenges, the goal is to optimize the sorting process for eligible PPE again, and also reduce the contamination risk. Also, at the same time, decreasing the cost, or it should not have a high cost. It should be efficient in cost. So, keeping that in mind, we were actually inspired by this project because we worked with a community based organization that was focused on separating materials like compost, landfill, and recyclable products. And we thought that we could take this idea to Ansell's Right Cycle program, where we can segregate PPE waste by brand, material, and hazard level. So the solution is to aim to reduce contamination and improve recycling efficiency. So what our solution does is it uses machine learning and computer vision to automate sorting PPE waste. It differentiates between different PPE items. For example, gloves compared to coats or other lab PPE. It separates brands like Kimtech and CleanGuard from other brands. It also differentiates or segregates by material. That is, it identifies nitrile gloves and polypropylene and other materials in the gloves. So that way, those can be segregated by material type. It also identifies if some of the materials were hazardous or contaminated versus if they were not contaminated and then segregate them as needed. So this automating sorting reduces human error, minimizes contamination, and lowers operational cost. And then the goal was again to design the method that can make sorting safer and more effective and less prone to contamination without adding external financial burden. So here, in order to solve this process, we proposed a machine learning and computer vision solution to automate PPE waste sorted by type, brand, and material. And here we've used image classification for brand and type, meaning we would train a computer vision model to identify PPE items by brand, that is Kimtech and CleanGuard, and material type as well. This will allow automated differentiation of acceptable items, reducing human dependency and contamination risk. And also, we could use object detection. There are advanced techniques in computer vision and object detection where you can have maybe a conveyor-based sorting system with cameras and sensors linked to the classification model. And as items pass through, the system directs them to specific bins, improving sorting speed, reducing contamination, and lowering cost through automation. Moving on, this is kind of like the process flow where PPE would be collected in bins. The bins would have QR codes or RFID scanners that would be used for tracking inventory automatically. And thereafter, the automating sorting and detection would start, where the PP items move on the conveyor system, where cameras and sensor capture images. Then we have a model for AI image classification that would detect Kimtech and CleanGuard brands compared to other brands, and also the material type would be detected to some extent. The non-hazardous material inspection could be detected by using infrared or hyperspectral imaging checks for hazardous material, prompting an alert system, and followed by segregation. Um, Sorted items will go to specific bins with the system monitoring levels to optimize pickup schedules and reduce emissions. So the key technologies that were used in here are the machine learning models. We've used EfficientNet, V0 or YOLO for brand detection. Model trains on labeled PPE images to distinguish Kimtech and CleanGuard brands for competitors. Object detection and segmentation for hazardous and non-hazardous material identification. Again, as mentioned, for the contaminated and the hazardous material segregation, we've used infrared and hyperspectral images as a suggestion that could work, which allows precise material type identification in terms of it was made out of nitrile or polypropylene. It detects the contamination based on spectral analysis, reducing the need for costly manual inspections. Again, sensors can be used. These are IoT-enabled cameras, weight sensors, or RFID/QR tracking, data aggregation for real-time monitoring of PPE collection and contamination levels, reducing labor cost and errors. This would result in real-time alerts sent if contamination or incorrect PPE brand is detected. And by integrating this with Ansell's ERP system for automated recycling reports, this could be automated, and it could greatly benefit Ansell with shipment schedules. So the key benefits are sustainability. It keeps more waste out of landfills, promoting efficient recycling. Efficiency in terms of reducing the need for manual sorting, saving time and resources. Scalability by applying advanced technology to support waste management for businesses and communities. And of course, environmental impact, where we want to lessen our landfills and other places by AI-driven sorting, and reduce that percentage to quite an extent by aligning technology and meeting our environmental growth goals, making sustainable waste practices achievable. How this can be achieved, again, as we mentioned, this can be done for the material type segregation, as mentioned earlier. We can do spectral imaging. Nitrile and polypropylene have different chemical compositions that can be identified using hyperspectral or multispectral imaging. These techniques capture images at different wavelengths, allowing us to analyze material-specific spectral signatures. For instance, nitrile might absorb or reflect light differently from polypropylene. So using these techniques, we can definitely identify the material and then segregate them. And again, the IR infrared thermography also can segregate materials like nitrile and polypropylene, responds differently to infrared lights due to their distinct thermal properties. So that's another technology that can be integrated to identify different materials in different PPE. So we had a prototype where we wanted to segregate organic waste compared to recycling waste. So we took this data set as a prototype, and we trained it using PyTorch, and we classified the images by actually deploying our model on Hugging Face. We could get an accuracy from anywhere between 80 to 100%. And here we gave an image of a strawberry and asked our model to tell us if it was organic waste or not. And it was easily able to identify that by 84% that it was organic waste. So likewise, the PPE can also be identified by brand after training models by given the labeled images. And as mentioned earlier, how these images can be differentiated by taking images through technology that can detect the differences. And again, by material type, using infrared or other high resolution cameras that can detect the difference between polypropylene or nitro gloves. And hazardous and non-hazardous material can also be detected through object detection models like YOLO, where it would localize your images, and then also be able to detect the presence or absence of hazardous or non-hazardous waste. So that's our research finding and implementation of the model on Hugging Face in short. And we think we can deploy this at Ansell and try to actually save them. Automate the process and save a lot of time doing this. Thank you for listening.